All right, folks. One more example using logarithmic differentiation to find the derivative. I'll find y prime here. And why are we going to use this technique again? Well, I've got a function of x as my base here, and then the exponent also involves a function of x. So in the previous video, we just did x raised to the x. Here I've got x raised to a function of x. So let's try this technique again, okay? So remember, step one is just apply natural log to both sides. Remember, the natural log property that we're trying to take advantage of here is being able to bring an exponent down out front. Because once we do that, then we've got a product, a multiplication, and the product rule is relatively simple to use. Okay, so that's our sort of goal with a method to this madness, the reasoning. So we want to say natural log of the left-hand side is equal to natural log of the right-hand side. All right, there we go. And now once we do that, then we want to, before we take our derivative, we want to simplify the right-hand side in this case. So we've got natural log of y is equal to, using our log property, bring the exponent out front, we get sine x times natural log of x. Cool. What do we do here? Apply d dx to both sides. So d dx of natural log of y is equal to d dx of sine x times natural log of x. Okay, so product rule over here. Over here, we got a little chain rule application. We're going to get y prime over y. I explained that a little bit in the previous video, so you can go ahead and double check that. And that's equal to, here, let me try to step through a product rule quickly. So I've got the first function times the derivative of the second function. So sine of x times the derivative of natural log of x is 1 over x. So sine times that is going to give me sine of x over x. Plus so we have our first function times the derivative of the second function, plus the derivative of the first function, cosine x times the original second function. So hopefully you can follow that. If not, step through that, applying your ddx's as you would for your product rule. And there we go. And now what I can do is finish this up by multiplying to the top, multiplying back both sides by y. So we want to isolate y prime, multiply this side by y, multiply all that by y. And so what do we have? All right, so you can pause it if you need to see. Pause and rewind if you need to copy down some of that work. But what we've got right now is y prime is equal to, let's say the original function, y, x sine of x, times the rest of this thing. And I'm just going to leave it the way it looks. Sine x over x plus cosine x times natural log of x. And is that cool? I guess so. Is there any kind of simplification I could try to do? Maybe distribute it in, but nothing's really going to clean up that much. So there we go. Got the derivative.